properties of a backward, central, average and difference operator. So here first we define a first order forward difference operator, and forward difference operator is only applicable if the given data have an equal class interval. Means difference between two successive values or two successive ordinate. Ordinate means the value of x, the value of an independent variable is always equal. So then we able to find out a what? Then we able to find out a forward difference operator. So what is the first order forward difference operator? Del fx is a f of x plus h minus fx. What is the second order? Del 2fx is a del f of x plus h minus del f of x. So if we try to write these difference operator in a tabular form, okay, tabular form, or so suppose this one is the ordinate. These are the values of ordinate. So this one is the ordinate, this one is the entity. Entry means entity. So what are the values of x? This one is the x0, this one is the x1, this one is the x2. Similarly, this one is the what? This one is the xn. So how many number of ordinates? Value of ordinate? There is a n plus 1 ordinate, because we started from the 0. x0 to xn, there is a n plus 1 values. Obviously, here the difference between x1 minus x0 is the what? H. Because here we try to define the forward difference operator. So this one is a what? x0 plus h. This one is a what? x0 plus 2h. 2h. And this one is a what? x0 plus nh. This one is x0 plus nh. Now, corresponding value of a y, and which one is also if we write in term of a f. This one is a what? This one is a y0, y1, y2, and this one is a yn. Similarly, what is the first order differences? Del y, this one is denoted by the del y. So y1 minus y0. So del y0, here we define a del y0, and this one equal what? y1 minus y0. Similarly, del y1 equal what? y2 minus y1. Similarly, last one is the what? Del yn minus 1 equal what? yn minus 1. This one is not a very tough process. This one is a very easy process. Means the difference of these y1 minus y0. Difference of these two is a del y1. And here, always we write the difference of these two in the mid of these two values. Always we write the difference of these two mid of these values. And this one is the mid of this one. So in each order there is a one less number of entity means one less number of terms from 0th order. This one is called 0th order. 0th order forward difference. This one is the first order. And similarly, if we define a second order, this one is a del y, and this one is the difference of these two. Means a del 2 y0 is a what? Del y1 minus del y0. Similarly, what will happen here? There is a one term less from previous number of term of a previous column. So as we proceed, as the number of order increases, the one term decreases one by one. Means here if there is an n plus 1 term, then there is an n term, there is an n minus 1 term, n minus 2 term, n minus 3 term, and so on. So similarly, what is the value of a del 2y1? Del 2y1 is a what? Del y2 minus del y1. And last value is a what? Del 2y n minus 2. This becomes del 2 del yn minus 1 yn minus 1 minus del yn minus 2. Okay. In a similar manner, what is the last? Is nth order del n y. Del n y have how many number of terms? There is one term. So term is a what? If we define this one become del n y0 equal what? Del n minus 1 y1 minus del n minus 1 y0. So in this way, be able to find out about n minus nth order differences. So these are the what? This one is a first order difference, this one is a second order difference, this one is a third order difference, this one is a nth order difference. So if we closely observe here and this table, if we write in a tabular form, means that this one is your first column, this one is your second column, similarly this one is your third column, fourth column, and similarly there is an nth column, then this one is called what? Difference table, forward difference table, not a difference table only. This one is called forward difference table. Forward difference table. Forward difference table. Difference table. Forward difference table. Forward difference table. Now, forward difference table. Similarly, if we write these values in terms of a backward difference operator, then this table will become what? Backward difference table. If we write this difference table in terms of a central difference operator, then this table will become what? Central difference table. So in general, there are three types of a table: forward difference table, backward difference table, and central difference table. So in terms of a notation, there is a difference between forward difference table, backward difference table, and central difference table. But in terms of a calculation, there is no any difference between forward difference table, backward difference table, and central difference. Because always, what will happen in a backward difference operator? Backward difference operator, this become what? Del y1 become what? y1 minus y0. Means here we write this one is a del y0 in terms of a what? In terms of a forward difference operator. But in terms of a backward difference operator, we write this one is a what? Backward difference y1. This one is a forward difference y0. But what is the right hand side? Right hand side of both difference operator are equal. So in terms of a calculation, there is no any difference between what? Between forward difference table, backward difference table, and central difference table. But in terms of a notation, there is a difference between forward difference table, backward difference table, and central difference table. Means in a forward difference table, first order difference, first term denoted by the first term represent what? Del y0. But in a backward difference table, the first term represent what? The backward difference of a y1. But the value of a del y0 equal to what? Del y1. Forward difference operator of a y0 equal to what? Equal to the backward difference operator of a y1. So once again, I repeat this statement. There is nothing else difference between forward difference table and backward difference table in terms of a calculation. But in terms of a notation, there is a difference between forward difference table, backward difference table, and central difference table. So just we take a simple example and try to explain means how we find our difference table. How we suppose there is a x and y is a given. X and y is a given. So suppose this one is about 1, 5. There is a difference of 2 means 3, then 5, then 7, and then suppose this one is a 9. Difference this one is for equal class interval because forward backward difference operator is defined for the forward backward whatever the difference operator we defined earlier. These are the for the equal class interval. So here the difference is a 2, here difference is also 2, difference is a 2, difference is a 2. So what is the value of s is a 2. So suppose the value for y is a what? The value for y is a suppose this one is a 1, this one is a 9, this one is a 25, this one is a 49. Suppose this one is a what? 81. So, what is the first order difference? First order difference, 9 minus 1, this one is a 8, del y. If we write it here, this one is a 8. 25 minus 9, this one is a what? 16. This one is a 24. This one is a what? This one is a 32. 9 minus 5, this one is a 4. 4 minus 2, this one is a 11 minus 9, 2, this one. Okay. So this one is a forward difference. It's a first order forward difference. Because what? Del f of x0, del y0 is a what? y1 minus y0. And del y1 is a what? This one is also y1 minus y0. So, del y1 is a what? y1 minus y0. If we try to find out the backward difference of a y0, this becomes y0 minus y minus 1. But there is no any term of a y minus 1. If we started from this one is a what? x0. This one is a what? x1. This one is a x2. This one is a x3. This one is a x4. So corresponding values with the y0, y1, y2, y3, y4. So in terms of a backward difference operator, in terms of a forward difference, this one is a del y0. In terms of a backward difference operator of a y1. This one 8 represent what? Del y1, backward difference operator of a y1, forward difference operator of a y0 is what? 8. So in terms of a calculation, there is no any difference between forward difference operator, forward difference table and backward difference table. Now, similarly second order forward difference. So what is the difference here? 8. And what is the difference here? This one is also 8. What is the difference here? This one is also 8. Okay, so this one is a del 2y, and similarly, if you find a del 3y, this one is a what? 0. This one is a what? 0. And del 4y, fourth order difference is also equal to 0. So, one very important observation from this table. So, if we closely observe the values of x and y, so if x is a 1, then value is a what? Y. If value of x is a 3, then value of y is a 9. Value of x is a 5, then this one is a what? 25, 7, 49, 9, 81. Then this one is a y is a square of a x. 1 square, this one is a 1. 3 square, this one is a 9. 5 square, this one is a 25. 7 square, this one is a 49. 9 square, this one is a 81. This means directly we write this one is a what? Y equal x square. Now, here one very important property of this difference table or this forward difference. This one is a polynomial of a degree 2. Polynomial of a degree 2. If the data satisfy a polynomial of a degree 2, then second difference become what? Second difference become constant. And third onwards, all other difference become 0. Means if this one is a polynomial of a degree 2, if the given data satisfy a polynomial of a degree 2, then second order difference become constant and third order onwards difference become 0. If this one is a polynomial of a degree 3, then what will happen? Third difference become constant and fourth onward difference become 0. So, and if this one is a have a nth degree polynomial, then nth difference become constant and n plus 1 difference and so on become 0. So this one is a very important result, and we use this result in future for interpolation and all other things. But here first mathematically we try to describe this result. Means nth difference of nth degree polynomial is a what? Nth degree polynomial is a constant. So one other things, One another things here, how many number of terms here? 5 terms. 5 terms, so if we find a del 3y, similarly if we find a del 4y, this one is also a 0, this one is a del 4y 0. So suppose this one is not equal to 0, this one also does not equal to 0. So what do you think about this one? How many number of terms here? 1, 2, 3, 4, 5 terms. So what is the maximum order of forward difference that we able to obtain? We able to obtain a 4th order difference. If the number of a term is a 5, then maximum order of a difference is what? 4. So if there is a n plus 1 term, so what is the maximum degree of a polynomial that we able to fit? So if there is a 5 term, so maximum degree of a polynomial is what? 4. Because 5th onwards difference becomes 0. So similarly, if we try to generalize this one, if there is a n plus 1 term, then maximum order of a forward difference that we are able to obtain is a nth order difference, and using the property of this difference table, we say that we able to fit nth degree polynomial if we have n plus 1 known values. So theoretically we try to prove these results. Means as we see here, the nth difference of nth degree polynomial is a constant, or n plus 1 difference of nth degree polynomial is a 0. So theorem is a nth difference means here we consider only the forward. This one is a true also for the backward, for the central, and all other operator also. Nth difference of nth degree polynomial is constant. Okay. So now how we prove this one? The nth difference of nth degree polynomial is a constant. How we prove this term? Now, for sake of simplicity, here we consider a polynomial of a degree n. So y equal xn. Suppose y equal xn be the polynomial of a degree n. For sake of simplicity, here only we consider a polynomial of a degree n means y equal xn. You may also consider y equal a0 plus a1x plus a2x square up to an xn with the polynomial of a degree n. Now suppose y equal xn be the polynomial of a degree n. So what is the first order forward difference? And the definition of a forward difference, del f of x equal del y equal what? F of x plus h minus fx. F of x plus h minus fx. Now what is the value of a del y? Del y means not a backward, this one is a forward. So if we write here, this one is a del y equal what? This one is a y, means a y equal fx. If we write here fx, if fx is a x to power n, then what is the value of f of x plus h? This becomes x plus h to power n minus fx is a what? X. So if binomially we expand this one, what is the value of this one? Del y become x to power n plus nc1 x to power n minus 1 into h plus nc2 means other terms of lesser power. Other term with lesser power, having less power. So this one is the expansion of what? X plus h minus x. So if we simplify this one cancel. This one cancel. So what is the remaining term? If we simplify this one, nc1 become what? N. So n x to power n minus 1 h plus, there is a coefficient, this one is a xn minus 2 and so on. So, and last one is what? Last one is a constant. So if we closely observe, what is the degree of this polynomial? Degree of this polynomial is n. What is the degree of this polynomial? Degree of this polynomial is n minus 1. Degree of this polynomial is n minus 1. Now, similarly, if we find the second order difference, so what is the second order difference? Second order difference become what? Del 2y equal del f of x plus h minus del f of x. Del f of x. So this one is a what? Del f of x. So this one is a what? Del f of x. Del f of x. This one is a what? Del f of x. So this one is a del f of x. So how we find the del 2y? Del 2y, this become del f of x plus h, means here we write f, in place of x we write x plus h. So what will happen with the first term? This become del f of x plus h minus del fx del y1 minus del y0. In term of y we write x0 plus h. So del f of x plus h become what? And h, if we write the first term only, this one is a what? X plus h to power what? N minus 1. X plus h to power n minus 1. Similarly, we write the second term, third term and so on. Only we consider here first term. Minus nh x plus x to power what? N minus 1. This one is the first term. Similarly, second term and so on. This one is the first term and second term and so on. Only we consider the first term and we ignore all other terms. If we ignore this one and expand this one, then del 2y become what? Del 2y become n minus 1 h square x to power n minus 2 and lesser power terms. This one is the first term. So if you closely observe here, y have a polynomial of a degree n, del y be the polynomial of a degree n minus 1, del 2y be the polynomial of a degree n minus 2. Polynomial of a degree n minus 2. In a similar manner, what is the nth difference? Nth difference become del ny equal n minus 1, n minus 2 up to n minus 1, so this become 1. And here, if this one is a 2, then this one is a h square. If this one is a 1, then this one is a h to power 1. If this one is a 0, then power 0. Now, this one become what? H to power n. Now, what is the value of x to power? If this one is a 2, then this one is a n minus 2. Then this one is a what? X n minus n. This one is a x0. And this one become what? Constant. This one equal to what? 0. And this become what? This become constant. X0 become 1. So what is the del ny? If we write in terms of factorial, del ny is a what? Factorial n h to power n. Okay? So this one is a proof of this theorem, because what? Nth difference become what? N is a constant, h is also a constant. So this term become what? This term become constant. So nth difference of a nth degree polynomial is a what? Nth difference of a nth degree polynomial is a constant. So this one is a proof of a theorem. Now we use this result of this theorem. Means how we use this result? We try to find out the missing terms. So how we find the missing terms? Okay. So we find the missing terms. What is the meaning of this one missing term? Suppose x is a given here. X is a given what? 0, 1, 2, 3 and 4. 4. And y is a what? Y is also a, y is a given 1, 3 and this one is a 9 and this one is a, suppose this one is a missing term and here this one is a T1. Suppose this one is a missing term. Now our aim is to find out this missing term. Now how we find this missing term? So if we denote this one is a what? This one is a y0. Y0, this one is a what? Y1. This one is a what? Y2. This one is a what? Y3. This one is a what? This one is a Y4. So what is the missing term? Missing term is a Y3. Y3. So we need to find out the value for what? We need to find out the value for Y3. So how we find the value for Y3? So how many number of unknown values with us? 1, 2, 3, 4. 4 value or known values with us. And we know that if we have a n plus 1 values, then nth difference become constant and n plus 1 difference becomes 0. So if we have 4 values, 4 known values, then we able to fit a polynomial of a degree 4 only or 3 only. So the fourth difference become what? Fourth difference become 0. This means del 4 y0 is a what? Same. Del 4 y0 is a what? Del 4 y0 is a 0. Why del 4 y0 is a 0? Because we have a what? 4 known values. 1, 2, 3, 4 known values. With the help of a 4 known values, only we able to fit the polynomial of a degree 3. So nth difference of nth degree polynomial is a constant, n plus 1 difference becomes 0. So del 4 y0 equal to 0. So if we write del 4 in terms of a shift operator, what is the in terms of a shift operator? This one is a e minus 1. Del equal what? E minus 1. E minus 1 to power 4. Y0 equal to what? 0. So if we expand this one, what is the value for this one? E to power 4. E to power 4 minus 4c1 e cube plus 4c2 e square plus 4c3 e plus 4c4 e0. What? This one y0 equal to. So if we operate here y0, so just we simplify this one. If we simplify this one, then this become what? E to power 4 minus 4c1. 4c1, what is the value of 4c1? Factorial 4 divided by factorial 3 into factorial 1. So this one is a 4 e cube. What is the value of a 4c2? This one is a factorial 4, factorial 2. So this one is a 6e square. 6e square. And this one become what? This one become again 4. This one is a minus plus, this one is a minus plus, and this one is a 4e, and this one is a what? Plus e0, and y0. This one is a 0. Now we operate this one on a difference operator, then e4, e to power 4 y0 minus 4 e cube y0 plus 6 e square y0 plus 4 e y0 plus what? y0. So this is a plus, minus, just we check this one, because this one is a minus. So we write down this one minus, this one is a plus, minus, and this one is also a minus, not a plus. So this one equal to what? This one equal to 0. So what is the value of e4 y0? e4 y0 become what? This value shifted to the 4 values. So e0 is a y1, e4 y0 become what? y4. This become what? e4 y0 become y4 minus 4 e cube of a y0 become y3 plus 6 y2 minus 4 y1 plus y0 equal to what? Equal to 0. Now we have values of what? We have a values of y0, y1, y2 and y4. Only unknown values of what? y3. So if you put the values of here, y4 is a what? 81. 81 minus 4 into y3. y3 is the unknown value. Here we write y3 plus 6 into y2. y2 is a what? 9 minus 4 into y1. y1 is a what? 3. 3 plus y0 is a what? y0 is a 1. This one equal to 0. If we simplify this one, 81 minus 4 y3 plus 54 minus 12 plus 1, this one equals 0. Okay, so what is the value for this one? I think this one is a 55 plus 54 plus 1, 55. 55 minus 12, this one become what? 81 minus 4y3, and this one become what? This one become 42. 42 plus this one become 43. This one equal to 0. Then minus 4y3. Yeah, 4y3 equal what? This one is a 124. And y3 equal what? This one is a 31. This one is a what? This one is a missing term. So what is the value for y3? y3 is a 31. This one we find with the help of a what? With the help of a difference operator, shift difference operator. Also we find this missing value with the help of a difference table also. How we find? Here y3 equal to 31. Similarly, there are two missing terms. Two missing terms, then how many number of known values? 1, 2, 3 known values. Then what will happen? Third difference become constant and a third difference becomes 0, and fourth onwards also becomes 0, means second difference become constant. So here we write del 3 y0 equal to 0, del 3 y1 equal to 0. There is a two known values and two equation. Then we solve the simultaneous equation with two unknowns, and there is a two equation. Then we are able to find out two unknown values, two missing terms. Now with the help of a difference table, how we find this one? How we find the value of a missing term? With the help of a difference table. So how we find the value of a missing term with the help of a difference table? Suppose this one is a del y. So what is the difference between this one? 3 minus 1, this one is a 2. 9 minus 3, this one is a what? 6. And this one here we consider the y3. Simply y3. So this one become what? y3 minus 9, and here 81 minus what? y3. Now what is the value of a del 2y? Del 2y. So this one is a 6 minus 2, this one is a 4. This one is a y3 minus 9 minus 6. This one is a minus 15. And this one is a 81 minus y2y3 minus 2y3 and plus 9. So this one becomes 2y3 equal to what? Minus 2y3 plus 9. Now what is the third order difference. Third order difference. Now third order difference become what? y3 minus 15 minus 4, this one is a minus 19. And this one become what? Minus 2y3 plus 19 minus y3, this become minus 3y3 minus 3y3 plus 90 plus 15, this become plus 105. 105. Now, what is the difference of this one? Del 4y. Del 4y, this one is a minus 3y minus y3, this one is a minus 4y3. And this one become what? 124. 124. So, what we conclude here? We conclude here, how many number of unknown values? 1, 2, 3, 4. 4 known values, so the fourth difference becomes 0. So, fourth difference must be equal to 0. So, if fourth difference must be equal to 0, so what will happen? If this one equal to 0, so 4y3 equal what? 4 3y equal 124 and y3 equal what? 31. 31. So, here there is a one missing term. And suppose there is a two missing term. So suppose this one is also missing. So here we write what? y1. There is a two missing terms. So two missing terms. So how many number of unknown values? 1, 2, 3. So the third difference become what? 0. The third difference, there is a two equations. Now here y1 and y3 is the unknown values. Now if we calculate in a similar manner, this one is an equation in terms of a y1 and y3, and this one is also an equation in terms of a y1 and y3. There is a two equation because third difference equal to 0. So this one also equal to 0, this one also equal to 0. If there is a two unknown values, so this one equal to 0, this one also equal to 0. So there is a two equation and two unknowns. So we solve this simultaneous equation, we find the unknown value, means a y1 and y3. Similarly, if there is a 3 unknown values or 4 unknown values, then in a similar manner we find a 3 linear equation, and similarly we find a 4 linear equation, 4 simultaneous equation and 4 unknowns. Then it depends on the how many number of missing terms and how many number of known values. As the number of known values is larger and missing term is less, then accuracy is higher in comparison of if missing term is larger in comparison of known values. So this one is one application how we find the missing term with the help of a difference table as well as missing term with the help of a difference operator. Also there is one application means how we find the next term of the sequence. So for example, how we find the next term of a sequence? Any sequence is a given. Suppose any sequence is a given. So suppose this one is a given, means 8, 12, 19, 29, 42 is a given. 42 is a given. So how we find the next value? Obviously, if this sequence is a given, this one is corresponding to the what? This one is corresponding to the 1, this one is corresponding to the 2, this one is corresponding to the 3, this one is corresponding to the 4, this one is corresponding to the 5. So next term is a given. So if we start from the y0, y1, y2, y3, y4, y5, because our standard notation is the x0, x1, x2, x3. So this one is a y0, this one is a y2, this one is a y2, this one is a y3, this one is a y4. So next term is the what? So y5. So how we find the value of a y5? y5 is the what? If we write y5 is the what? E5 of a y0. E5 of a y0. Now, E5 of a y0, and here we write 1 plus delta to power 5 y0. This one is the what? y5. We expand this one. We expand this one binomially. Binomially, then this one is the what? Binomially, we expand this one 1 plus 5c1 del plus 5c2 del square and so on. So, and y0. So, how many number of terms is required? Because there is a 1, 2, 3, 4, 5 known values, then only if 5 known values, then only be able to find out a fourth order difference. So, only here need to write what? Fourth order differences. Means be able to find out a 0 difference, be able to find out a first order difference, be able to find out a second order, similarly, be able to find out a fourth order differences. So, here we write y0 plus 5c1 of a first order difference, 5c2 of a second order difference, 5c3 of a third order difference, 5c4 of a fourth order difference. Then here y0, y1, y2, y3, y4 is a given, then we are able to find out about first order difference. First order difference, difference of a y1 minus y0, y2 minus y1, y3 minus y2, y4 minus y3. In other words, we say that if we construct the difference table, once we construct the difference table, then we are able to find out the value of a what? Del y0, del 2y0, del 3y0, del 4y0. And once we find the value of y0, del y0, del 2y0, del 3y0 and del 4y0, then putting the values here, then we find the value of a what? Then we find the value of a y5. So this one is a what? This one is another application of a what? Difference operator or difference table. Means with the help of a difference table, we find what? We find a missing term. And with the help of a difference table, we find the next term of the sequence, or first term of the sequence, or middle term of the sequence. Middle term of the sequence. And this one is also just like a what? Just like a missing term. So this one is a missing term, last term is a missing term. Here first term is a missing term, maybe mid term is a missing term. So with the help of a difference table, we also able to find out next term of the sequence, also be able to find out missing terms. There are many more applications. So in the next lecture, we discuss about interpolation. Okay, thank you.